chemistry students. Today we're going to study our first lesson on nuclear chemistry, one where we focus on particles and radiation that are important to nuclear chemistry. Before we get into this, we have to remember how we can symbolize the nucleus of an atom or any isotope. We write the symbol of the element or the particle. To the left we have two numbers, the atomic number and the mass number. Remember, the mass number is the sum of the protons and neutrons in the nucleus. The atomic number is the number of protons. We can figure out the number of neutrons with these two numbers because the mass number, protons and neutrons, minus just the protons, will give us the number of neutrons in an atom. This is a carbon-12 atom. We know there's 6 protons because this is printed to the left on the bottom, but we know that anyway because carbon will always have 6 protons. And then there are 12 protons and neutrons altogether in the nucleus. There must be 6 neutrons since 12 minus 6 is 6. So that's how we can symbolize this carbon-12 isotope. This method of symbolizing information about the nucleus is going to be critical for all the different types of particles that we study in this lesson. The first particle that we'll look at is the alpha particle. This is a helium nucleus. We can symbolize it with the Greek letter alpha, or we can symbolize it with more chemical information about that particle itself. Since it's a helium nucleus, we can use the symbol for helium, put 2 as the atomic number, since it is helium, the number of protons, and then 4 for the mass number, because there are 2 neutrons and 2 protons, totaling 4 particles in the nucleus. Because this is just the helium nucleus, the charge is going to be +2 from the 2 positively charged protons. The mass is 4. The only thing in this particle are protons and neutrons. Each has a mass of 1 AMU, so the total mass is 4. Alpha particles are the weakest of the 3 particles, or the 3 big types of particles in radiation that we'll discuss, and it can be stopped by a sheet of paper. So a single sheet of paper can stop and block an alpha particle. The next particle is the beta particle. It is a high energy electron. We can symbolize the beta particle as this Greek letter B, or beta, or we can symbolize it like this, 0 minus 1 E. The lowercase e stands for electron. 0 is the mass number. There are no protons and no neutrons. It is a single electron. Then we'll put a -1 for the atomic number. It really doesn't have any protons, but we'll put a -1 here to serve as that value. The charge is -1 because it is an electron. The mass is extraordinarily small, very, very small. I never write 0 because there is a mass. It's just so tiny. It's practically 0. Beta particles can be stopped by a sheet of metal. Gamma is actually not a particle, it's a radiation. It's high energy radiation. We can symbolize gamma with this Greek letter. There's no other way to symbolize it since it's not a particle. There's no symbol, there's no protons or neutrons. The charge is 0 and the mass is 0 because there's no particle nature to gamma. It is just radiation. Gamma radiation can be stopped by centimeters of lead or several feet of concrete. So this is the strongest and most energetic of the 3 things we've talked about so far. There's a couple other particles that are important to our study of nuclear chemistry, one of which is the neutron. We've already learned about the neutron as part of the atom. Now we'll learn how to symbolize it and how it fits in with these other particles. We can symbolize a neutron with 1, 0, N. This hopefully makes sense because as a single neutron, the mass number comes from 1 neutron. 0 protons must have a mass number of 1. And like I said, 0 protons is why we place a 0 here. The lowercase n is the symbol. The charge of a neutron is 0 because it is neutral, and the mass is 1. The final particle is the positron. The positron is a positive electron. We symbolize it just like we symbolize the electron, except instead of a -1, we put a +1 here for the atomic number because it's positive. It's just like an electron, only it's positive. 0 + 1, 8. The charge is +1. It's a positive electron, so it will have a charge of +1. The mass is extraordinarily small. It's identical to an electron except for the fact that it has a positive charge. So the mass is extremely small, practically 0, but it does have a mass because it is matter, it is a particle. So we've covered alpha, beta, gamma, neutron, positron. You need to know about these 5 things: the charge, the mass, how we symbolize it, and what can block these different particles in radiation.